Hey Fixsters, and welcome to this video where I want to show you real quick how to remove duplicates from a Python list of lists. So I've already recorded a video that shows you how to remove duplicates from a Python list, but I found that if you have a list of lists, then things are quite different. Because, so a list of lists contains list elements by itself, but a list is a mutable data structure, so you can change it later. That's why you cannot use sets to sets and dictionaries on list objects. Yeah, so you cannot, for example, use a list as a key for a set or for a dictionary entry. And therefore, because of this, you cannot use some of the methods that are best suited to remove duplicates from a Python list. And that's why I want to dive into the method of removing duplicates from a Python list of lists. Okay, so what is I always start with the naive method, the simple method how to do things. And this might be suitable for many of you actually, because if you don't care about performance, then just use this method. If you have small list data sets, then it's the best method. Okay, first you create an empty list dub-free, and this contains all elements in the list, but from the original list, but only the ones that are not already in the list. Okay, so it's duplicate free, as the name suggests. And then you go over all elements in the original list and you check if X not in dub free, then you add it to the list. Okay, because if it is not already in the list, then you can simply append it to the end of the list. If it is if it is already in the list dub free, then of course you have already the element, and adding it would create a new duplicate, which you don't want. So therefore you simply skip this. Yeah, you don't enter the if statement, which means that you just skip the whole thing, skip the whole loop body, and move on to the next element. Okay, and this means that the elements, this means that the elements are added in the same order they appear in the original list. So if you would print the result here of dub free, you get the list of lists with removed duplicates. Okay, here you have 4 elements, and now you have removed all duplicates of the list. So which means that, yeah, this element and this element, these lists are the same. So they contain the same data. They are not the same object in memory, but they contain the same data. So those two lists, like if I create 2 lists, 1, 1, and check whether this list is the same as this list, 1, 1, then it will return true. Okay, so even if those lists are different objects in memory, they will also, so if you use comparison, they will evaluate to true. They will create, so the equality operator evaluates to true, even if the lists are different in memory. If you want to check the same whether those lists refer to the same memory address, by the way, then you can use this one. Oh no, it doesn't work in Python. Okay, so no worries, just ignore what I just said. Good. So this is like the naive method of checking whether of removing all duplicates from a list. Sorry, I was just confused for a moment. Good, but why is this a problem? Because here you go, if the list has n elements, you go over all elements in the list, and then you check for each element if this is not already in the dub-free list. And in the worst case, the dub-free list already has like more or less n elements. So in an average case, it will have n half elements. So for example, if you don't have a single duplicate in the list, then you will add elements to the dub-free list. And if you have n elements in the original list, like say million elements in the original list, then on average you will have 500,000 elements in the dub-free list. So this means that if you call this line here membership, so you check membership of a list element in the list, then you have to compare 500,000 elements. Yeah, so if the list has really like up to 1 million elements, and on average you have to do 500,000 comparisons to check whether this element is in the list or not. And so this operation has linear runtime complexity because it's linear in the number of elements. If you increase the number of elements, like a list from 500,000 to 1 million, so you double the number of elements, and you also double the runtime complexity, the expected runtime complexity, so the expected runtime of the algorithm. So you double the x value doubles the y value. That's why it's linear. And this one here also has linear runtime complexity, the outer loop, okay? So we go over all elements and go over all elements in the inner loop, okay? So we have n times n comparisons or operations in worst case, okay? So therefore, as we have like quadratic runtime complexity, this is not optimal. So there are some constant time algorithms to remove all duplicates from a given list, and that's what I want to show you next. Okay, so one like simple method is based on sets, and it's based on set conversion. So basically, here we have this. Here we have the same thing, but now we can we simply create another variable called dub-free set. It contains the same elements, but it's now a set, yeah? So here we create a new set object, and we simply add the same element we add to dub-free. But in order to check this, here in this line, this has linear runtime complexity. Now we check if x not in dub-free set, okay? So we check, we do like set membership operation instead of list membership operation. In the list, to check whether an element exists in a list takes n operations, so you have to go over all elements in the list in the worst case. But to check whether an element is in the set is only one single iteration. Yeah, you just hash the value. Sets are implemented with hash tables, so you just hash the value you want to check, and you go into the hash table cell and you check whether this element exists there. So it's constant runtime complexity. Now, no matter how large the set is, checking the membership of an element takes a constant amount of time, in principle. So therefore, this operation now is only constant runtime complexity instead of linear runtime complexity, which means that we need only like n, we need to enter the loop n times for n elements, and here we have one operation and here we have one operation, so we have like 2n operations. It's a bit more because this append operation consists of multiple operations, but I mean, you know what I mean. It's just like having 2n or 3n or 4n operations, but not n squared complexity, because we don't have to go over the whole data structure in each loop iteration. We like have here constant runtime complexity, and but now it doesn't work already because the dub-free set is now empty. Okay, so what do we want to have in this dub-free set? The dub-free set should contain exactly the same elements as the dub-free list. Okay, so therefore each time we add an element to dub-free, we also add an element to dub-free set. Okay, so it works like this. So it looks strange, but it's the most efficient way to do it. Okay, so we just so here if we add an element to the original data structure, we also add an element to our helper data structure, to our set. And now it still doesn't work. Why? Because here we the element x is a list, and as you see here, you cannot add elements to a, like say you create a list lst, it's empty initially, and now you want to append. Let's create not an empty list, but like a list with 2 elements, and now we create a set, and now we try to call append the list to the set. So we want to actually, no, I think the append doesn't work on set. We need to use add. So we want to add the list to the set, and this doesn't work because here you see the error message is type error unhashable type list. Okay, this means you cannot add list elements to a set. This doesn't work, as I pointed out in the beginning. Okay, so therefore, as you cannot do this, by the way, we have to use add here. As you cannot do this, you have to convert it to a tuple. So let's check whether tuple works. A tuple is an immutable data structure, so you cannot change it after creating it. Okay, so you create a tuple once, and then you cannot change it anymore. Okay, then it stays like as is, and of course now as the data structure is like constant, immutable, you can hash it, and everything works properly. So you can create a set of tuples, but you cannot create a set of lists. And so for example, we can call sadd tuple of list, and now if we print set, you see it's a set. It contains one element, which is this tuple element. Okay, so a set of one element, which is a tuple. So we can add tuples to a set. So therefore, we need to convert this to a tuple here using the tuple constructor, and we need to convert this one also, because here we check in a dub-free set, we check whether the tuple of x is actually in the dub-free set or not. And yeah, so this conversion, it's also very quick. It costs only constant runtime, and so therefore this is very efficient. It works beautifully. If you, I mean, you can have one little optimization. You can create a tuple here basically, and then use the variable t here. Okay, so now you have to do only one tuple conversion. Okay, and that's basically the most, I would say, effective and also most understandable way of doing it. There's an alternative with dictionary conversion to create a list of lists, but removing all the duplicates. But I won't go into detail because I find it is more complicated to understand and it doesn't have better runtime behavior. So I would just stick to this method, which I find is superior to the alternative with the dictionary comprehension. But if you are interested in dictionary conversion, then check out the link in the description below. Also, if you want to gain some practice, I mean, this is now theoretical stuff, yeah. So it's important to understand those. Don't get me wrong, but it's much more important that you apply your skills in practice. So even if you are a coder, often coders are like introverts or shy. They don't want to go outside and meet with clients. And but this is really, I mean, meet with clients and get some practice, gain confidence in the marketplace. This is the most important thing you can do to increase your earning potential to the market. And even as a coder, no matter where you work, even if you want to work at Google or so, you need to communicate with other people. So communication skills and business skills are at least as important as Python programming skills. So you need to have all three to become a well-rounded software developer. And that's why I have created a course based on my experience and my path towards becoming a successful online business owner in the coding space. Yeah, I have created a free webinar. You can check it out. The link is also in the video description below. So check out the free webinar, how to become, how to build your high income skill Python, basically. I will give you all success secret and how you can create an online business as a Python freelancer. And that thrives, and you can work on the site 4 hours per day or even 3 hours per day. So I have one course member, Adam. He also records video. He's also freelancer for Thingster, my online business, and he works part-time, only 2 to 3 hours a day, earning like full-time income, and yeah, the rest of the time he enjoys. He told me once that he goes snowboarding and stuff in Eastern Europe. So he basically lives in a low income country, but earns high income. So therefore, he doesn't need to work a lot to fund his dream lifestyle. So it really works out in the 21st century. Freelancing is the new job opportunity of the 21st century. Even if you need to work from home, freelancing is perfect, and it will only grow. I mean, the marketplace of Python freelancers grows for years, for decades, I would say, and now already, and it will keep growing. Why? Because it's the most efficient way to broker work in a globalized economy. So everybody can access talent online and on freelancing platforms, and everybody can focus on his talent and sell his talents online. Okay, so it's much more efficient if I can write and you can code, then let me write your stuff and you code my stuff, and both of us will ultimately work less and have better results as a result of this transaction. So it makes a lot of sense for the economy, and it will only grow in the future. So check out my free webinar or even my course, How to Become a Python Freelancer. I have links in the description below. Okay, thanks for watching the video and see you in the next video. Bye.